Okay, we're going to implement a stack using two queues. And so just to get an idea of how that will work, we'll just have some random numbers here. We can go through a quick example. Okay, so we've got some numbers. And so if we wanted to load all of these into the queue or into the stack, we would have two queues, Q1 and Q2. Just kind of make these. Okay, so what we're going to do is take the first element that we want to put in and put it into Q1. And then at this point, we would put anything that's in Q2 into Q1. But there's nothing in Q2, and then we swap. So this becomes Q1, this is Q2. And then we go to the next element, and it goes into Q1. And then we go through Q2, and we dequeue all of Q2 into Q1. So the 2 goes in there. And then we swap. And we go to our next element, and we in-queue that into 1. And then we dequeue Q2 into Q1. And then we go swapping. Okay, and so then we go to our 6 here, and 6 goes into Q1, and then we dequeue Q2 into Q1. Okay, and then we swap. And we go with our next element, 12, and then we dequeue Q2. Okay, and so on and so forth, and we swap. Okay, so the goal is to always have all of the elements in Q2 at the end of each in queuing stage. So at each push to the stack, you're going to end with all the elements in Q2. And that will be very important for when we do our pop and our peak, because they will operate on Q2. All right, so let's go ahead and write some code. So we know we need a, let's go ahead and do a class. We can make it public. We'll just call it stack from queue. Okay, and so in that, we're going to need a queue of ints. We'll just call that Q1. And we'll get some room here. Okay, and then we also need a Q2. Spell that a little better. Of ints. Okay, and then let's go ahead and write our push function first. So okay, and it's going to take in the data. Okay, and then so the first thing we wanted to do is we wanted to put that into Q1. So we in-queue the data. And then the next thing we wanted to do was then dequeue Q2 into Q1. So while Q2.count is greater than 0, we want to say Q1 dot NQ Q2 dot DQ. Okay. And then after we've emptied all of Q2 into Q1, then we need to do our swap. So we can say we have a temp, and that's equal to Q1. And then we have Q1 equals Q2, and Q2 equals Q1. Oh, no, sorry, Q2 equals temp. That makes a lot more sense. Okay. Equals temp. Okay, so there's our push. That's all there is to it. And when we go to pop, we're going to say pop. And all we have to do is we'll put a little exception in there first if Q2, because remember everything has to have is inside Q2 at the end of our push. If Q2 is, then we'll just throw an exception. Stack is empty. Okay, and then we'll just return Q2.DQ. Okay, and that's all we have to do for pop. And then we can do a peak. And that's going to be kind of the same thing as pop, except we're not actually popping it off. So Q2.count is less than or equal to 0. Then we're going to throw our exception. Stack is empty. And otherwise, we're going to return Q2.peak. Okay. All right, so that should take care of getting all our functionality into for our stack. So let's go ahead and run through our example here. So I'm going to make this a little bigger. We've got 2, 4, 8, 6, 12, and 18. Okay, so let's go ahead and keep track of Q1 and Q2. Okay. All right, so first thing we want to do is we want to push our 2. So we're going to Q1.enqueue data. Okay, while Q2's count is greater than 0 and Q2's count is 0 right now. So we'll skip that. And then we swap and we say our temp is Q1. That's just going to be a placeholder. Q1 is Q2 and Q2 equals our temp. That was Q1. Okay, so let's say we want to push the next item. It's going to Q1.enqueue, it's 4. Then while Q2.count is greater than 0, so right now the count is 1, then we would dequeue Q2 and enqueue it into Q1. Okay, and then we can do another one and we could say, oh, and we have to swap. That's what's next. So this is Q2, this is Q1. And so then if we were to push another item, we could push the 8 to Q1. Then we DQ Q2 into Q1. Okay, and swap. All right, and then let's say we want to add this next item, goes into Q1, then we DQ Q2. Okay, and then we swap. Now let's say we wanted to go in and pop, then it would be if Q2.count is less than or equal to 0, we throw an exception. That's not the case. So we would return Q2.DQ. So we'd be popping this 6 and returning it. That's our pop. And now we just have the 8, the 4, and the 2 kind of in our Q2. If we wanted to peak, then if Q2.count is less than or equal to 0, it's not. So return Q2.peak. So we would return 8. Okay, and let's say we wanted to go ahead and NQ something else. So we get to the 12, and let's say we want to put 12 in. So a 12 would go into Q1. Then we would DQ Q2, be 8 and 4 and 2. And then we would swap. Okay. So now we have those numbers in, and then let's go ahead and load this 18 in lastly, 18, and then we DQ. Okay, and then we swap. All right, and let's say we wanted to pop, we would end up returning 18. And then if we wanted to peak, we would return 12. All right, it looks like it's working. So all the operations for push, pop, and peak happen in O of 1 time. Well, actually, for the push, it would be worst case, it would actually be O of n, because we have to, it would be O of n minus 1, because we have to push everything into Q2, or everything from Q2 into Q1 each time we reload. So our push is O of n, which is really it's O of n minus 1. And then our pop is O of 1, and our peak is O of 1. And for our space, we utilized 2 Qs. So that would be O of 2n space. All right, and that should do it.